Hello, this lecture is on section 5.2 from the Larson book, Normal Distribution, Finding Probabilities. Now I mentioned up here that you can use a basic scientific calculator and the probability table, but the way I've been presenting the lectures, it's more technology based now than it used to be. So looking at the calculator or Excel, which I would recommend. Now we've talked a little bit about these, and you've seen the normal CDF, so you're going to see it again. So I'm just kind of showing the idea of the inequalities. I guess when I first created this video, I had not used the normal CDF before in section 5.1, but we've already used it now, so we ought to be kind of familiar with some of this down here. And then there you go, the negative 1e, 1e, the 99. So I'm not going to read through this, but it's probably a good idea if you do. But you've already kind of seen some of this done. All right. Except for this last part. Now, here, we've been dealing with random variable z, which is your standard normal distribution, which has mean 0 and standard deviation 1. In this section, we're going to deal with just a variety of normal distributions with different means and distributions, and we're going to see how to enter that. All right. Okay. Now, what you're going to see, like I said, the normal CDF now is, we had that 0, 1 was in there as the default, but we're going to enter whatever the mean and standard deviation is given in the problem. So what we're going to do is just do some examples here of applications where the data, we assume it's normally distributed. With some sort of mean and standard deviation. And we're going to calculate probabilities of certain events happening based on that information. So I've kind of got the old school way to do it there and there too, but you don't have to worry about that. You can just decide how you want to handle it. So we got a normal distribution that has a mean of 200 and a standard deviation of 40. Okay. And the first question says, find the probability that a bulb selected at random lasts more than 250 hours. Okay. So using you would convert this, if you're kind of doing it the chart way, you would convert it to Z, like we saw in that last section, how to convert a value to a Z if we needed to. So you take 250 minus 400, and you get 1.25, and if you're using the chart, you wouldn't want to flip it over and change the sign and make it negative. Look it up, get 0.1056. Okay, so that's how you would do it that way. Let's focus on our calculator and Excel way here. The normal CDF greater than, see, the normal CDF and the calculator, you don't have to convert it to this Z. That's the beauty of it. I mean, you can convert it to the Z and then do it, but you don't need to. As long as you put the mean and standard deviation in there, it takes care of it for you. So I'll put, X is greater than 250. So I put the 1e to the 99 in there to represent positive infinity. The mean is 200. The standard deviation is 40. And there we have it, and we have 0.1056. I just rewrote this as a percentage. We may see problems. You might see one on a test where, the answers are in percent forms, but that's certainly not difficult to do. All you're doing is multiplying your decimal answer times 100. Okay. And in now see, okay, in Excel, we're using a different function now. It's called norm dist. Not norm SDist. Norm SDist, S was for standard normal distribution, meaning your mean is 0 and your standard deviation is 1. Now norm dist needs you to tell it what the mean and standard deviation are. And that's what we want. We want to tell it what it is. So we put our X value in, 250. We tell it the mean is 200 and standard deviation is 40, and it's still going to be true. But we do 1 minus. I didn't show the answer there, but I would not have posted this in the notes if it did not produce that answer, but maybe I should do it anyway. So let's come over here, and I could bring stuff up. I'll copy. Yeah, I could maybe copy these, and I have to change them to norm dist. Okay, so let's put paste right there. Okay. So I want this 1 minus 1, the last one here. Except now I'm going to change the command to norm dist. And it's telling me across the top there it wants the x value, the mean, the standard deviation, and cumulative, meaning true. So the x is 250. Means 200. 40 is the standard deviation, and there's true. So now I'll just copy this back into the notes and save that. Yeah, I guess when I did these the first time, I would have looked to see what the answer was, but I didn't bother copying the answer. But now I think I will. Yeah, I would not have just left an incorrect answer thing there. So there it is. Excellent. Now the next one says find the probability that the bulb will last between 180 and 210 hours. All right, fair enough. All right, I'll skip the old school method of it there. Calculator, you do normal CDF, you put 180 as your lower, 210 as your upper, the mean 200, standard deviation 40, hit paste, there are all the values, and that has 2902, which is what I got right here. And norm dist, anytime it's between two numbers, yeah, it doesn't matter whether it's norm s dist or norm dist. Meaning, if you got to do 1 minus, you got to do 1 minus either way. And same thing here, you have to subtract whenever it's between two numbers. So I think I'll put that one back in there just so we can, hopefully I'll have to shrink it in probably a little bit just to fit the answer in there. That's okay. So it's 210 at 180 and 210. I actually should have copied. Well, that's okay. I'll get rid of these parentheses and the 1 minus, which I don't need. Norm dist. So I need 210. Means 200. Standard deviation 40. Let's come over here. I got to change the S, get rid of the S, and it'll be 180. And same mean and standard deviation. Got to get rid of the right parentheses there. So if not, that will be a syntax error. I either had to leave them both or get rid of both. Ooh, let me stretch this out so we can see it. All right, whatever I did, I didn't mean to click that. What in the world happened here? All right, I paused whatever button I hit to mess all that up. I paused it to fix it. It's going to be hard to shrink in there and keep the answer, but we can try. Okay, well, that's going to fit in there all right. Wonderful. I'll go ahead and save the notes. So I'll be reposting them anyway. All right, Dodge Durango auto transmission gets an average of 18 miles per gallon in the city with a standard deviation of 1.5 miles per gallon. What is the probability that a Durango selected at random gets more than 20 miles per gallon? Assume the mileage is normally distributed. Okay, so we'll skip the converting it to Z and using the chart, and I'll jump right down here. And like I said, you'll see more of these in the calculator, especially as we get to the homework for sure, but I'm hoping you can see what's going on here. So greater than means you start at 20 and you finish with 1e to the 99 for positive infinity. You put in 18. You put in 1.5 for your standard deviation, and there you have it. And I'll just copy this over so I don't mess it up here. So I'll just keep toggling back and forth. Let's put it over there somewhere. Yes, I'm just going to go right to this norm dist at the bottom and just type that right in there. (18) 1.5 and true. And there we go. 0.092 looks good. So let's copy that 0912. Let's copy that to the notes. Oh, and the wrong notes. It's the last section, so here's our section. And there we have it. So let's look at this example. So I may not re-enter some of these. I'll just kind of explain them real quick since they're already here. And like I said, we'll be doing some fresh problems. There's one right down here we can do. So let's just kind of walk through these, and I won't say, I'm not going to, yeah, even though the norm dists all need to be redone, I may type them in there later myself before I publish the notes again. Let's just save you some time here. Like I said, you're going to see this done in the homework, so live action for both ways. All right, means 100, standard deviations 12. We select a water bill at random. Find the probability that the bill is less than 80. So there's kind of the old-fashioned way, which I, kind of want to leave in the notes there. I'm not ready to totally get rid of that idea yet, even though we're not required to have to use that method. So less than means on normal CDF, you start with the negative 1e to the 99 as being negative infinity. You put 80, you put 100 for the mean, you put 12 for the standard deviation. And you get 0.0478. And norm.dist, 180 is the x value. Because it's less than, that means you don't have to do any kind of 1 minus or anything. 100 is the mean, 12 standard deviation, true, and that's going to give us this answer. And the reason why this is off a little bit, I don't know if I've mentioned this in the last section or not, I'm not sure if I said it, but anyway, it's because, and it won't, on a test, it might actually have this pink answer, but if you get this answer, just pick that one that's very close. There won't be a bunch of answers that are that close together. But I'll tell you at least what the reason is some of these test banks I use and stuff, they have this if it was done being the old method with the chart. And because you round the Z to 2 decimal places, it's not as precise as the technology, because the technology can calculate that area with more decimals in there for the Z. So that's what makes the answer a little bit different. So technically the calculators and Excel are more precise because they're using more decimals for the Z. Now, if your Z calculates to something where rounding wasn't necessary, then they're pretty much going to match up. Let's say if it was exactly negative 1.5, perfect. And yeah, then they're going to match because no rounding was involved. So basically the difference between this one and the technology is if this is negative 1.67, that meant really it was going to be negative 1.666666 or whatever, and it can use a bunch of those sixes over here. Anyway, between 95 and 128, excuse me, 95 and 128. Normal CDF, when you're between two values, you lower than upper. There's no E of the 99s. 100 for the mean, 12 for the standard deviation. Now for the norm dist, and same thing for norm S dist, but that's not relevant here. But you have to subtract them. It's not like, it's not like the the calculator where you don't have to do that. So you just put 128 in there, 100 for the mean, 12 then true, then the lower number, 95, 100, then 12 and true. And that's going to match the same answer. More than 138? Now the calculator, so more than means you start with your number and you go to the 1e to the 99, 100, and then 12. Now this is just scientific notation. This e to the negative 4 basically means times 10 to the negative 4. It basically means you move the decimal back 4 places. Move it 4, and it's going to leave 3 zeros in front of it. So the number is actually 0.00077, but the 77 then would round to 8. I think I'll put that one in the calculator right now, in Excel right now. 138. $100. Okay, 12. Yeah, you see it's 0077. Of course, you can format this to round to 4 decimal places if you want to. You can make it do it, and you don't have to do it. Okay, I'll shrink this in a bit. All right, I don't know where that just went. Oh, there it is. All right, just kind of shove that in a little bit. Cut this one out. There we go. Now here's one more than 85, so basically the same kind of problem. So you see the normal CDF just changes this from 138 is the first number, now becomes 85. And then the norm dist just changes then the first number from, I'll type that one in again, because it'd be real easy to do here since it's already set up with the mean and standard deviations already set up. So all I got to do is just change this 138 to 85. Super quick and easy. All right. Oh, okay. Here I'm explaining okay. This is explaining what I've already said about the chart value being on test sometimes and not matching up because of the rounding. So, okay, so that's all that's talking about. So, meaning if you don't get a perfect match, that's okay. You know, just go with the closest answer on a test. Now, of course, in the homework, that's not going to matter at all because it's going to accept the technology answers. Let's take a look at this one. Average person time a person spends on social media per day is 49 minutes. Assume the standard deviation is 16 minutes and the times are normally distributed. So that's just there to verify that we can use the normal distribution. What is the probability that we will a person selected at random will spend more than 60 minutes on social media in a given day? Greater than, so you can do it either way. Calculator, start with 60, go to 1e to the 99 for positive infinity, 49 and 16, 2458 or 2459, and we can check the norm dist here. I'll just cut that out and paste it because I'll just paste the new one with the answer. All right, just makes it easier this way so I can see all the numbers, not have to memorize them. 49. There we have it. Wonderful. Let's see, suppose SAT math scores are normally distributed with a mean of 518 and a standard deviation of 115. What percent or probability, now, okay, what percent of the scores are less than 500, which is also saying the same thing. It means the same exact thing as the percent would just be given, as a percent, but it would be the probability of any one person having a score less than 500. So those are synonymous. And so less than in the normal CDF, you do this as negative 1e 99, 500, 518, and we can't see it, but then the 115 standard deviation would be at the end. And because it's less than, it's just regular norm dist, no 1 minus or anything. 500 is our x value. 518 is the mean, 115 standard deviation, and true. And like I said, I'll probably repost this with verifying it matches that answer, but we can go ahead and go on to part B for now. Okay. Let's see. All right, so what does part B say here? I'm going to read that while I'm doing this up here. Don't like the font. It's too big. If 1,500 scores are selected at random, about how many scores would we expect to be less than 500? Now, way back in the first unit there, we had a problem like this with a pie chart. And what we took the example where if you had a total amount of people and whatever percent of the pie is, you multiply it by the percentage, and that would tell you how many people belong to that particular thing. Okay, same idea here. There's not pie charts or anything like that. Is you just take the percentage, the answer that we get, and you multiply it by the total number of people. Now I put the squiggly equals here. It's just multiplication in the calculator. 4, 3, 7, 8, 1500. The answer has to be a whole number because it's a number of scores. So you can't. So and you can just use normal rounding on this. I don't know what that number is. We can check real quick. But it's not any special thing like class width where you have to round up or anything like that. You can just use normal rounding, round to the nearest integer. I guess I just didn't put this in there, but I guess I can add it in there now that I'm doing it. But it's just straight up multiplication. So yeah, I guess I can just snip this in here. All right. I didn't get the snipping tool, did I? That's what I meant to get. Oh, there we go. Yeah, so I'll just snip this out, even though there was nothing, special being done in the calculator here, but it doesn't hurt to put it there. Like I say, normal rounding, so we got 657. Okay. Let's take a look at some homework problems from this section. Now it's number 2. That's pretty much, I have that one in one of my notes, kind of the same thing, utility bill. I could go back, maybe do it. Anyway, I certainly could do it if you need to see the help. This next one pretty much accomplishes exactly the same thing. It has a less than, a greater than, between 2 and greater than, the 3 scenarios that we're likely to see. Now, so let's see what we got here. Bring up. Got a mean of 25 minutes and a standard deviation of 6. Find the probability that a randomly selected athlete uses the stair climber for less than 25 minutes. So we'll bring up the calculator. And we'll use this middle section here. These are the ones where it's not just the standard normal, like the first 3 were for the first section. We use norm dist instead of norm s dist. Let me come over here to the calculator. And we use normal CDF, except the difference now and before is we will not be using 0 and 1 for the mean and standard deviation. We'll be using whatever it gives us in the problem. So this one was means 25, standard deviation 6. I'll go ahead and jump down, then go back up. Then let's go back up here and see. I believe it was a less than 20. So less than means I have to use -1 EE to the 99. Or 21? 20. No, 20 here, and then get back and put the 25 in there where it was. All right, now let me put this in Excel. So less than will be the top one. And the Excel, we put the value we're checking, which is 20. And then 25 was the mean. And standard deviation, I believe, was 10. 6. Oh, I believe wrong. Oh, great. I hate when this happens. 6. So how about that? 2, 2, 0, 2, 3, both answers. So I feel pretty good about that. Between 25 and 33. All right, so the smaller number than the larger number. And it still has 33, and it still has the 25 and the 6 in there. So we leave that. Enter. Now Excel, we have to use the bottom one of the middle section, because that's how you do between in Excel. It has to be done as a subtraction. So all I got to do is change that. I got to change a lot of stuff here. It's 25 and 33, so the first one will be 33. And then 25. And then 6. And then 25, 25, and 6. There we go. Looks like both of them are showing 4088 rounded. So let's go with 4088. Beautiful. Now the next one's more than 40 minutes. So in the calculator, we would have to go more than 40. Means we start with 40, and then we use the 1e to the 99 for the to represent positive infinity. Okay. Now let's see how that works in the spreadsheet. More than will be the middle one. So 40 is the number, the x value. Next thing's the mean. And then the standard deviation of 6. And always true. Always true for these in the normal distribution. In the binomial distribution, we sometimes, you could use true or false depending on the scenario, of course, not just randomly using true or false, but here it's always true. That looks good. 0062. Beautiful. Let's take a look at the next one. Okay. So we have adult IQ scores are normally distributed, mean 100, standard deviation 20. Find the probability that a randomly selected adult has an IQ of less than 132. So here we can go. Less than means we start negative 1 e to the 99 up to 132. And mean is 100. standard deviation of 6. Let's see if we can match that in Excel. So the less than will be the top one. 132 is the x value. $100 is the mean. Standard deviation was, is it 10? 20. Good thing I look. And true. Let's see that. How about 9452 for both of them? I like it. Can't get to 9452. Wonderful. All right, here's an IQ question again. It just has different numbers. 105 and 15 are a mean. And this one is between 86 and 124. So in the calculator, we have second distribution, normal CDF. The lower is 86. The upper is 124. Mean 105. Standard deviation 15. All right, let's see if we can match that in Excel. It's going to be the bottom one, because that's when you're between two numbers. Upper's 124. Lower's 86. And then the mean 105 and 15. Okay. So I put 105 and 15 into these two spots. And we'll do it for the other one. $7,947 for both answers. I like it. Let's see how we did. Fantastic. All right, well, that includes this section, 6.2 normal distribution, part 2.